So my name is Richard Rauser, and just make sure this is working all right. Nearly there. Here we go. And so I've been here at Just Eat for about 14 months now. Currently working on the MMA team. It's the mobile marketing attribution team. I'm the tech lead on the team, and what we're all about is instrumenting the mobile apps with all sorts of analytics and then tracking what users do after they follow certain ads into the app. So it's pretty interesting, but it's not what we're here to talk about, of course. We're here to talk about cryptocurrency. And I won't profess to be an expert, but it's certainly an area that I've watched for a number of years and been fascinated by. And so I've kind of put together what I consider to be a kind of a crash course in cryptocurrency. It's kind of like a primer for people that maybe aren't so familiar with various different aspects of it. More geared towards people that are new to cryptocurrency, but I think even people that maybe know something about it will still walk away with a few new pieces of knowledge. And I appreciate that. Yeah, being a technical audience, we're all probably fairly familiar with what cryptocurrency is all about. So really the best place to start, of course, is with Bitcoin. And it wasn't the first digital currency, of course. There's been digital currencies almost since the beginning of information systems, whether that be, karma on a message board or some sort of asset that you collect within a video game. But Bitcoin was the first cryptocurrency backed by cryptography that reached any sort of scale. And the thing is, even though the idea of a cryptocurrency is fairly new, the technologies behind it are actually pretty old. If you think about it, cryptography, and specifically public key cryptography, dates back to 1976. It's almost, more than 40 years old. And then peer-to-peer networking. If you think about it, Usenet was a peer-to-peer network. That, again, is also 40 years old. And then a ledger system. Well, this goes back probably even before recorded history. Ledgers have been around for thousands of years. And the combination of these three technologies are what make Bitcoin special. And I think a lot of times when you hear things spoken about cryptocurrency, people focus so much on the currency aspect and kind of don't focus enough on the underlying technologies and why they make it special. And the truth is, Bitcoin as a currency or as a payment system, that is just a single feature of these three technologies. But there's many other use cases, many other features that can be built on top of these technologies that are even more powerful than a currency on its own. And so we'll kind of dive into that later. But first, let's talk about Satoshi Nakamoto. We're probably all familiar with this guy. He is the mythical figure of Bitcoin who wrote the seminal paper in 2008 describing what Bitcoin is. It's only 9 pages long. I'd encourage you to go read it. It's actually quite fascinating. And the way he describes it is as a peer-to-peer electronic cash system, or alternatively, an electronic payment system based on cryptographic proof instead of trust. And I think it's quite interesting that he doesn't actually mention anything about currency itself. It's about an electronic cash system, a payment system. And that's that one use case built on top of those three technologies we were just looking at. Now, Satoshi is an interesting character. He's probably Nick Szabo, an American cryptographer who's responsible for a lot of the innovations we see in cryptocurrencies today. Don't know for sure. But I think probably the most noteworthy fact about him is that he owns almost 1 million Bitcoins. That's worth, almost $6 billion US dollars in today's money. And he's never spent a single one, except for in test transactions. So I find that kind of interesting. Anyway, so that's the way he describes it. And when I'm talking about cryptocurrency, I tend to use this phrase here. It's an entirely electronic cash payment system that is both decentralized and distributed. So what do we mean by that? Well, decentralized, there's no central arbiter or authority that controls the currency. This is what makes it special. And instead, it relies on cryptographic hashing for managing the money supply and managing the network. And if you think about traditional currencies, fiat currencies, you probably all know this, but a fiat currency is paper money, currency that has value because a government says so, by fiat, by diktat. They usually have some sort of central body that buffers the effects of the market that hit that currency. So we've got the European Central Bank, we've got the Bank of England, the Fed in the States. If, let's say, inflation is running super high, what are they going to do? Well, they've got a bunch of levers at their disposal. They can increase interest rates so that they're paying more in credit card debt, more in mortgages, and they have less disposable income. And similarly, there's other tools at their disposal like quantitative easing to increase money supply if perhaps not enough is being invested into businesses and so on. With a cryptocurrency, you don't have those options. It's all based on cryptographic proof, and the money supply grows monotonically. And if you think about the context in which Satoshi actually wrote that original paper, it was post-credit crunch. There was a lot of skepticism about banks. And I think we have to bear that in mind. So as we go through this discussion of cryptocurrency, I'm not just going to focus on the technical aspects, but also some of the cultural and political aspects of cryptocurrencies, because I think there's some of the most powerful elements of this phenomenon that we're witnessing today. So decentralized, key aspect of it, but also it's distributed. So if you have a Bitcoin wallet, you're part of a peer-to-peer network that is constantly shooting messages around, transmitting messages, potentially verifying them, validating them, potentially adding them to the blockchain. And there's a lot of them. At any given time, there's about 10,000 nodes running on the Bitcoin network right now. It's not any different from Napster or from BitTorrent or any other peer-to-peer software you might have used in the past. So that I just pulled off a node last month, and you can see that the peer-to-peer network of Bitcoin, it spans the globe now. It's it's everywhere. So Bitcoin, what are the key components? And we'll talk through these one by one. We've got a wallet, the peer-to-peer network, we've got the distributed ledger. What is the Bitcoin wallet? Well, it allows you to send and receive currency, but it doesn't actually hold any currency. And that's probably not a misconception in this room, but a lot of people that aren't so technical don't get that it's just really a set of keys. It's a private key and a public key. And that private key is what you use to send transactions. We all understand public key cryptography. I, as the holder of a private key that is a secret that I don't share with anyone else, I can digitally sign a message, and then anyone with that public key, which is available to anyone to use, can verify that I'm the only person that could have sent that message. And so in the context of Bitcoin, I'm the only person that could have transmitted some value to, say, Ollie in the back over there. I signed you 10 Bitcoins, and everyone knows it's me because I signed that message at the end of it. And then if I do send him money, I send it to his public key address. And that public key is stored within the blockchain ledger, and that's how we know how much money you've got in terms of Bitcoin. And so if I want to send a transaction to Bitcoin, I want to Ollie, that 10 Bitcoins, I have a message, a data structure that contains the value that I want to send, the date and the time, various other parameters, digitally sign it, and then it goes onto something called the mempool. And if Ollie first fires up his wallet, the first thing it's going to do, if he's never run it before, it's going to query DNS. It's going to download a list of the nodes, the random nodes that DNS provides, and then it's going to query each one of those nodes for its list of nodes. And then your client ends up with a whole list of nodes that it uses to interact with the Bitcoin network. And so if I want to send a transaction, I'll broadcast it to all the nodes that I've got in my my client, and then those in turn will broadcast the message to all the clients that they're aware of. And yeah, we get exponential growth, and it doesn't take long, usually seconds, potentially minutes, before every node in the graph knows about that transaction. But there is a problem here, because at this point, we know that I sent that transaction. I've digitally signed it. It only could have been me that sent it. But I could also send 10 Bitcoins to Vlad over here. You're very welcome. And another 10 Bitcoins to Magda. You're welcome as well. And the thing is, how do we know how many Bitcoins I have? Am I able to send these Bitcoins to you guys? Well, we need a way to verify that. And that's where the blockchain comes in. And so it's just a distributed ledger. We all know what a ledger is. It's just a record of financial transactions have existed since the beginning of time. And in this case, it's shared, it's public, and it's part of the peer-to-peer protocol. And so it contains literally every transaction that's ever occurred in the Bitcoin network. So if you're running a wallet on your machine, then chances are that you've got the full Bitcoin blockchain on your machine. It's 150 gigabytes, takes forever to download and verify. But most nodes on the Bitcoin network are full nodes. There's also lightweight nodes that don't have the full blockchain. They're actually in the minority. So the blockchain, it contains every transaction. It's cryptographically verified as true. As I said, every node has a full copy, and it's also, in theory, immutable. But that's not strictly true. We'll discuss some examples of when blockchains have been changed in a bit. And of course, when we talk about a blockchain, it is a series of blocks. There's about 500,000 of them these days. But it begs the question, what exactly is a block? And this is where things start to get a bit interesting. So a block contains a set of transactions. And right now, it's about 2,500 transactions per block, maximum block size of 1 megabyte in Bitcoin. And those blocks that block is certified, it's cryptographically secured and known to be true. And the way that's done is in a process called mining and identifying a proof of work for that block. So proof of work is kind of at the core of Bitcoin, not of all cryptocurrencies, but Bitcoin certainly. It uses something called the Hashcash algorithm. So this algorithm was actually developed initially as a way to prevent spam email. And the idea was, if I wanted to receive an email, I'd also want whoever's sending it to me to solve some sort of hashing problem that was difficult enough that that if you wanted to send millions of messages, it just wouldn't be economic to send those messages. But to send it to just an email to just one person, that's fine. You just need to do that hash once. It takes a second or something like that. It never really caught on, but Hashcash has found a second lease on life with Bitcoin, in fact. And so it uses good old SHA-256 in order to hash. And the way it works is it takes several input values and then a nonce, and you've got to iterate over the nonce until you find a solution, a hash solution that meets certain criteria. So let's take a look at the inputs. You have the Hashcash version, the hash of the previous block in the chain. You've got the Merkle root of all transactions. Now, the Merkle root is basically a hash that's composed of all the other hashes. You get it by kind of hashing all the transactions of a tree till you get to the root. It's got a timestamp, it's got a bits, it's got a nonce. And what we literally do in order to mine is I've got this block of transactions, I've got these input values. I iterate over the nonce until I find a solution to the hash, the SHA-256, that has a certain number of zeros at the front of it. It's as simple as that. And when Bitcoin first started, it was only 20 zeros, but the difficulty has increased now. Now it's about 80 zeros. So there's literally billions upon billions and billions of solutions, potential solutions you have to try before you get one that actually fits the bill. And there could be several because you're only looking for a certain amount of zeros. Thank you, at the front. But as soon as you do, that block will be broadcast by a miner onto the network, and then other nodes will then verify it to be true. And as long as the first one and the proof of work is difficult enough and more difficult than any other block that's been submitted simultaneously, it gets added to the blockchain and it becomes true. So that's kind of a simplification of how it works. But as I mentioned, as the network hash rate increases, so does the hashing difficulty. And the reason for this is that the designer, Satoshi really, he only wanted there to be one new block every 10 minutes. And so as more hashing power becomes available on the Bitcoin network, we see the hash rate increase. So it's quite difficult now. It's so difficult that it's really impossible for any independent miner to be successful. You need to join a mining pool. And probably you need to be part of some massive Chinese kind of entity that's mining out there, where electricity is cheap. It's typically done with specialized hardware now, ASICs. It's not really economical to do it with GPUs even or CPUs. So mining has the effect of moderating the money supply. So each time a miner finds that successful hash, they kind of win a contest, and they get awarded currently 12.5 Bitcoins for that. It was 25 once upon a time. It was 50 before that. It gets halved every now and then. So this is kind of a simplification of what the blockchain looks like. Not pretty grainy, but you can see here we've got a block. It's got a set of transactions. It's got its own proof of work, which functions as its own ID as well, unique ID. And then we've got a reference to the previous block. And that, keep in mind that the proof of work for this guy, it actually takes as input that previous block hash as well as the transactions and the version, all that other information. So we kind of know that that proof of work could only have been generated by this having been the previous block, and then with its hash included in the input of the next hash. I think now what I want to do is just escape out of this and show you what the blockchain looks like, because there's a great little web interface here. It's called the Block Explorer, and if you want to kind of sorry, Ollie. There's not a finite number of transactions in the blockchain, but each block can only hold about a maximum of 2,500 transactions. And the limiting factor is the 1 megabyte max size of a block. So it varies, but typically it's about 2,500 transactions these days. In the early days, when there weren't many transactions going out on the network, then you could have blocks with only 20 or 30 transactions in them, much smaller. Stopped mining. Well, we would have a problem. You wouldn't be able to send transactions. The blockchain would not be built up. Yeah, that would be a problem. But you'd have to be pretty silly to stop mining right now. If everyone stopped mining, then someone else is going to start mining, and because the hash rate is so low, you're going to be generating blocks super quickly. And with Bitcoin at $5,500, then yeah, you'd be earning a lot. So I think people are incentivized against doing that. But anyway, this is the Block Explorer, so you can see the latest blocks that have been mined. If you're interested in what the blockchain looks like, I encourage you to just have a crack at this, and let's just dive into what a block looks like. So we can see the hash up here. There's actually many more zeros here. This is just a a small part of it. But you can see the number of transactions that were in this block. That's actually quite rare to see it that low these days. You can see the block height. That's just the index of the block. So there are about almost 500,000 right now. You can see that the miner got 12.5 Bitcoins for this guy, the timestamp and so on. All this stuff goes into the proof of work, the block hash. And then you can see the difficulty over there, the bits, the size, and so on. Let's scroll down a bit. And you can see the transactions encapsulated in this. So this first one, it's called the Coinbase. And it is the transaction that rewards the miner with the 12.5 Bitcoins that he should have earned for finding the hash for this block. You can see he's earned about 13 Bitcoins for that. So he got 12.5 that were freshly minted, and then there's also fees attached. So if you want your transaction to go through faster, you can attach a fee to it, and then it'll be higher prioritized, and miners will be more highly incentivized to mine that transaction, included in the block. I think where things get really, really interesting, what mining pool is this? Doesn't actually say here. What I find is really interesting is when you see this mined by field here, let's see if we can find one. Antminer, this probably won't be too interesting, but some of the big miners like BTCC, you have a look at the address that the Coinbase gets transferred into, and it's scary how much Bitcoin is actually associated with that address. It'll be tens of billions of US dollars worth of Bitcoin, and it's just kind of funny to think that someone out there controls that amount of money at a single Bitcoin address. And pardon me? Why don't they use what? Sorry. And a lot of people do, but a lot of miners don't. They don't really care, particularly in China. So you do see, if you look at the throughput through certain addresses, you'll see that, yeah, it's literally been tens of billions of US dollars worth of Bitcoin, and pretty far out. Anyway, I kind of love just kind of scrolling through this. You can see the number of confirmations here. So typically, if like the first time I bought a round of drinks in a bar in Shoreditch several years ago, pardon me? Anyway, it was a few years ago. In hindsight, it was by far the most expensive round of drinks I ever bought, and I do regret it. But typically what a merchant will want to do, they'll want to see the first confirmation. They'll want to see it appear on the blockchain. So I had to wait 7 or 8 minutes before that transaction was actually confirmed by being added to the blockchain. That's painful, and it kind of calls into question whether Bitcoin is actually effective as a currency. And furthermore, many merchants, they want to see another 5 confirmations before they accept the transaction as valid. Oh my God. So you could be sitting there for up to an hour waiting to know if the merchant is going to accept the payment. And that's not too cool. I mean, it makes Bitcoin kind of questionable as an actual currency that you can use day to day to buy coffees or what have you. But where Bitcoin has better application is, let's say I want to transfer money to the US today. Well, it's probably not going to appear in that US account for 3 or 4 days, whereas I could use Bitcoin to transfer it there within an hour with all the necessary confirmations for the counterparty to consider it to be valid. So that's where it has more of an application. So let's ditch this and get back into the presentation. So blockchain. I hope that's all clear. It's a heady concept. And just a little bit more about the peer-to-peer protocol. So when I fire up my wallet, sitting on my laptop or on my phone, what have you, the first thing it'll attempt to do, if it's a full node, it'll attempt to build the blockchain from the Genesis block. This is after it's got a list of all the nodes that from DNS or what have you. And that Genesis block, it's literally hard-coded into every Bitcoin client, included in the reference implementation, Bitcoin Core as well. And then literally what it'll start doing is asking the peer-to-peer network for more blocks, and it'll build up the blockchain. And given that it's 150 gig in size right now, it takes a long time. But that's not the only thing that causes it to take a long time. Basically, it's required of Bitcoin clients to actually verify that each block is accurate. So we've got to verify the Hashcash proof, that proof of work, for each one of the blocks that we consume. So that ends up being a lot of hashing that's required just to build the blockchain. So if you were to start from scratch, if you were to download Bitcoin Core today, which is the reference implementation of a Bitcoin wallet, it would probably take you more than a week before you've actually built the whole blockchain today. Now, there's many other Bitcoin wallets that work off chain and that are just lightweight clients, and so there's ways around that. Yeah. So I want to talk more about the scalability and performance concerns of Bitcoin. So a good way of thinking about this is in transactions per second, and what PayPal is capable of. They're capable of transmitting about 115 transactions per second. Visa, this is the biggest payment network in the world, of course. They transmit about 2,000 transactions per second. Does anyone want to venture a guess about how many transactions per second Bitcoin is able to? 2? Yeah, you know it. Yeah, you know it. This guy knows his stuff. It's about 7. So yeah, it's 7. This is a big problem. And so it's because of the 1 megabyte block size and that we can only mine 1 every 10 minutes. And there's a lot of kind of innovations, suggestions about how we can do something about that. Segregated witness, 2x you might have heard of. There's also, of course, been forks from Bitcoin. So Bitcoin Cash, they actually increase the block size to 8 megabytes, which increases throughput by a lot, but still not significant enough to get to this point. And so yeah, there are some real scalability and performance issues here that draw into question whether Bitcoin's ever truly going to be effective as a currency. And the one thing that kind of lingers in my mind is that particularly in the software world, it's never the first person to the market, very rarely the first person to the market that becomes the long-term success. Facebook was not the first social network. Google was not the first search engine. Amazon was not the first marketplace. And Bitcoin, in my mind, is probably not going to be the enduring cryptocurrency because there's many others, many others. Now, I just want to pop into this a bit. You guys might have heard what Jamie Dimon said recently about Bitcoin. So he's on record for saying all sorts of horrible things about Bitcoin. He just can't shut up about it. In fact, he keeps talking about how he's going to shut up about Bitcoin, and then he says another kind of thing debasing Bitcoin. He considers it a fraud, worse than tulips, and he thinks that anyone working for him, if he caught them trading Bitcoin, he would fire them. Yeah, great, whatever. But you got to consider the context. Bitcoin and cryptocurrencies in general represent a threat to people like him that are cozy with government, that have a real investment in the existing monetary system, that benefit from the fiat currency system. And so it's actually not surprising that he would say things like this. But at the same time, I would say a lot of people within the Bitcoin community are now at the point where they believe that Jamie Dimon is saying these things just to talk down the price so he can get it at a bargain. But who knows if that's true or not. But in response to this, and this is the best response I saw, Zhao Yang, let them eat fiat. And that I think sums up the attitude entirely. Someone in a place of privilege in an ivory tower saying, Bitcoin's a fraud, forget about it, it'll never work. And of course, right now it does seem to be working. Anyway, I thought that was quite salient. So moving on, let's talk about altcoins. Yep, sorry. Pardon me? Yes, I am. And we're going to talk about that right now. Yeah, not in much detail, to be honest, but we're going to talk about altcoins, and any coin that is not Bitcoin but is a cryptocurrency is considered an altcoin. Yeah, Litecoin is one of them. So Litecoin was created by a Google engineer. Pardon me? Oh, I thought you said Lightning Network. Yeah, I know. And Litecoin uses the Lightning Network. So it does, yeah. So Litecoin, basically, it was created to kind of combat these issues within Bitcoin. The problem with Bitcoin right now is that it's reached such a level of maturity. It's very hard to get innovation introduced into Bitcoin because there's so many competing parties that all want their way, and it's very difficult to achieve consensus. So what you find is a common thing today is that people break away from Bitcoin, often just forking Bitcoin and creating it the way they want to. So Litecoin is a great example of that, created by a Google engineer. It uses a different hashing algorithm called S-script that can't take advantage of ASIC hardware, which is great, which makes the playing field a little bit more level. It also uses something called the Lightning Network to enable transactions to occur in seconds instead of minutes, which is really damn cool. So that's one example of yeah. There sure is, yeah. It's going to talk about that in dangers later, yeah. So you're right, there's a problem. If any one entity were to harness more than 50% of the mining power, then they're going to be able to turn out blocks faster than anyone else, and they can basically write the history of Bitcoin in any way that they so desire. And that is a real danger. And in fact, it's actually happened once before. In 2014, there was a company that did actually control for a very short amount of time more than 50% of the network. And pardon me? They could reject blocks, and they couldn't steal, but they could. Right. Sure. Yep. Good point. True. Yep. Cool. Anyway, so the other coin I'll mention now is Peercoin. And so Peercoin's claim to fame is that it doesn't use proof of work, which is part of the problem that we're discussing right now. Proof of work is subject to these kinds of attacks. Instead, it uses something called proof of stake, which not only has the effect of not having this problem with more than 51% of the hashing network being, if it were commandeered, being able to kind of take advantage of the currency, but also it means that we don't use as much hashing. There isn't any hashing power that gets kind of used up, and the amount of electricity that Bitcoin uses today, right now, is probably more. It's more than all of Iceland uses on a daily basis, and people are saying by 2020, the amount of power used by Bitcoin every day will exceed that used by Denmark. So this is, there's an environmental cost, quite frankly, and so it's a bit of a concern. So in the early days of altcoins, most of them were forks of Bitcoin. And in fact, Litecoin is a fork of Bitcoin. Peercoin is a fork of Bitcoin. There's many, many altcoins that are forks of Bitcoin. But that has changed in the past 2 years because there's one cryptocurrency that stands out above all others. And it's probably one you're familiar with, and that, of course, is Ethereum. So Ethereum has got something special going on with it. It's decentralized and it's distributed. It's built on a blockchain. It's mined similarly to Bitcoin, different hashing algorithm, but it's got a lot of similarities. It was proposed in 2013 by Vitaly Buterin. He's one of the kind of like the major figures of the cryptocurrency scene, and it went live in 2015. And its key innovation, and we spoke earlier about how the decentralized nature of the technologies behind Bitcoin can enable many different use cases, not just a payment system. And if you think about today, me personally, if Facebook decided to shut down my account for some arbitrary reason because I somehow got associated with terrorism or something like that, that would really piss me off. I'd lose my family photos, my vacation photos, all sorts of messages I might want to keep for every reason. Like, it's my personal diary. And more importantly, if Google for some reason decided to shut down my Gmail account, well, that's my primary email address. I've got all sorts of password resets configured to shoot back to it. I've got all sorts of interesting stuff in there that I definitely don't want to lose. But they can do that arbitrarily, and you got to question whether centralized power should have that authority. Let's think of an even more crazy idea, for instance. A hypothetical island in, I don't know, the South Pacific or something, and perhaps, it's got a poorly run government, and there's a guy who works at a title deed office, a property office, and he's not been paid in a few months, and so he decides he's going to walk back into the office, fill out one of the title deed cards for a perfect, beautiful piece of beach, waterfront property, and just change the name on it to, I don't know, his own. And suddenly he owns the property. Who's going to question that? How would anyone know? Particularly if it were previously owned by a dormant user, or maybe it was a national park or something like that. When you've got centralized authorities that manage assets, you get these problems. People are easily corrupted. And Ethereum is a cryptocurrency that's designed to get by that, by also providing a distributed Turing-complete virtual machine on top of it. So this is really damn cool. And you probably already are familiar with this, but the idea is that you can build any sort of software that you can imagine on top of a blockchain. And the only constraints you have really are performance and scalability, which are extreme. If you're building on top of the blockchain of Ethereum, you're probably talking about kind of early 90s, late 80s state of technology. Because think about it, it's got to run on a peer-to-peer network. The processing power is distributed, but it's pretty damn cool. And so what has happened is pretty much every new cryptocurrency, the vast majority of them that you hear about these days, they're actually now forks of Ethereum, or they're built on top of Ethereum. Ethereum makes that very easy with something called smart contracts. And this was a concept that was first proposed by Nick Szabo back in 1996. Again, this is the guy many people think is Satoshi Nakamoto. And what these smart contracts enable is the ability to build D-apps on top of the Ethereum blockchain. And you can build them for all sorts of different purposes. Probably trying to build a social network or an email system on top of it, that could be a little bit challenging. But the kind of things that we're hearing about that are probably doable are like identity management or real estate management or maybe some sort of asset trading, that sort of thing. Things that are kind of, in terms of performance and scalability, don't have huge requirements. There's 4 languages you can use to write for it. Solidity is by far the most common. It's what's called the contract-oriented language. You build DApps with it. It's very similar to JavaScript, but it is statically typed. And if you want to know more about it, there's great tutorials on the Ethereum website. The first is just a simple hello world. You publish a smart contract to the blockchain. It basically just responds to you when you send a transaction to it that includes something called gas, which is a payment that needs to be made when you want the contract to be executed. And then the second tutorial on the Ethereum website, I think this is really telling, is how to build your own cryptocurrency using Ethereum. And the reason why that is kind of funny, before we get to that actually, I can't talk about Ethereum without talking about the DAO, the DAO, Distributed Autonomous Organization. And I'm sure some of you have heard about this, but basically it's a great application of Ethereum. It's an investor-directed venture capital fund. The idea being that participants would put money into it, and in return for that cash, they would get the right to vote on how that money should be spent. And then people could submit proposals for startups, new technologies, or even like something like a new coffee shop. And people could vote on whether they wanted money from the DAO that they'd invested to go into that company. Great idea. I was captivated by it. I put money into it. Unfortunately, it didn't work out too well because within hours of having launched, $50 million was siphoned off of it. And in today's money, it's about $100 million. And considering the state of Ethereum back then, it was, God, an existential threat to its existence. Really, really, really tough stuff. And the way the way it was dealt with is they actually rolled back the blockchain to just before the hack happened, and then kind of forked it and carried on with that. And that's the Ethereum that we know today. So blockchains are not entirely immutable. That's the development community. Basically, the hashing power of the network, it was based on how much hashing power people could associate. I think it was more than half the hashing power of the Ethereum network voted in effect to kind of to fork it. So yeah, so I think that's actually particularly interesting. And I think what's even more interesting is that what's now known as Ethereum Classic, which is the original version that had the hack happen, is carried on. People are still investing in it. People are still mining it. And what's up? No one had to buy in. So basically, they rolled the blockchain back to the state just before the hack. And then if you owned Ethereum before that hack, then you would get Ethereum on both branches. So you would get ETH, which is the Ethereum, the safe Ethereum that carried on, that is now worth about $310 per Ether. And then you'd also have cash in ETC, Ethereum Classic, which is now worth about $10. So it's plummeted in value, but it's still valuable, and people are still mining it. And it's kind of surreal, and I think it actually speaks volumes to how frothy and how much of a bubble cryptocurrencies have become. That people are continuing to invest in something that we know has been hacked and that has a whole lot of stolen money on it. So kind of frightening. And also it was one of the first ICOs. At the time, it was by far the most high-profile ICO of all time. So you've probably heard about this in the media. Initial coin offerings, what the hell are they? So basically, it's akin to an initial public offering, when the process by which a company goes public on a stock market, but it's entirely different. If you're running an IPO, then you've got a cadre of lawyers kind of overseeing everything. You've got an investment bank behind you. You've got all sorts of due diligence and regulations that you have to comply with, and a big part of that is making sure that the company is safe to invest in. With ICOs, literally, it's a person or a couple guys getting together, putting together a white paper. I might recruit Ino over there for the 10 Bitcoins I sent you earlier or something, and put your name on it as some technologist, and I describe a use case for the cryptocurrency that I'm creating. And then a week later, I might publish an Ethereum address and a Bitcoin address and say, send me all your money. And then I'll guarantee that I convert this into some token that you can trade back for something valuable in the future. Yeah, it's super dodge. There's a lot of fraud going on in this space right now. And when Jamie Dimon is speaking about tulip bulbs and fraud in cryptocurrencies, this is the kind of thing he's talking about. ICOs are extremely dangerous. Maybe you're thinking right now, well, geez, I want to go do this. Second tutorial on the Ethereum website. How hard can it be? It's not hard. But you got to be very careful right now because the SEC is cottoning on to this. There's several people that have been tossed in front of the courts in the States right now with potential 20 years that they're looking at because they've not been careful about ensuring that the token that they're selling is not similar enough to a security, which of course means that you for them fall liable to all sorts of securities regulation in the States. It's super dodge. All the same, this year, 2017, has seen an explosion of ICOs, a huge number of them, and we've actually seen several that have extended to 9 digits. Filecoin is one, Tasos, Bancor, Sedis.im. All of these have raised basically hundreds of millions of US dollars worth of cryptocurrency on the basis of a white paper with nothing to show for it, no product. It's kind of bizarre. And as a kind of a testament to just how bizarre it is, the Tasos debacle. So just in the past week, Tasos, which is the biggest fundraising ICO of all time, raised $232 million US dollars, now worth $500 million US dollars in funds. They've got that sitting in a foundation in Switzerland, and there is a massive public battle raging between the two people, ex-Goldman Sachs bankers, who own all the IPO for Tasos, and the man who's managing the funds. And they're accusing each other of trying to siphon off money, and now they've got law firms involved, and a huge amount of that money is going to disappear on legal fees, and God, who knows what's going to happen to the project. It looks like it might go down the can. What's going to happen to that $500 million? I don't know. It's almost surreal, but this is the state of ICOs today. And a lot of people are predicting that actually traditional venture capital is going to see a real surge next year when people start to get seriously bit by the ICOs that are occurring now. So it's fascinating. It's interesting. And just, yeah, this is my last slide, really, on some of the dangers. Fraud, of course, as we've seen. Hacking is an issue. The 51% hashing problem we already discussed. Quantum computing. So a lot of people are saying that, it's something that's been well publicized, is that public key cryptography is at risk by quantum computing. And it's not just a problem for cryptocurrencies, which are based on public key cryptography, but also, the security that backs up, that handles bank machines and safe browsing on the internet. But it's there. One of the key things, a lot of economists point out this, is volatility and deflation. So Bitcoin, for instance, there's a fixed supply of Bitcoin. It's 21 million Bitcoins. And pretty much in any kind of, with any kind of asset where there is a fixed supply, where you can't increase the money supply like a central bank would do with quantitative easing or what have you, the volatility is huge. It goes up and down and up and down. And we've seen that with cryptocurrencies. There's no central bank to buffer the influences of the market. And more importantly, perhaps, is deflation. So as more and more people pile into Bitcoin, it's going to become more and more expensive. And of course, what that has the effect of doing is making goods look cheaper and cheaper. And deflation is, one of the bugbears of any economist, because why would you buy today what's going to be cheaper tomorrow? So this really calls into the question the ability for cryptocurrencies to function as currencies. Why would you spend any Bitcoin and people don't? They hold on to it as an asset. Why would you spend it on something when you could buy it for half that price in a week? And so some real concerns here. And then, of course, government bans regulation. This is another risk. Already ICOs and currency exchanges, cryptocurrency exchanges are banned in China. They're banned in South Korea. They're banned in Russia. Most Western economies are not banning them yet. What we're probably going to see instead is some very strict regulation of cryptocurrencies. What that means, I don't know, because a lot of people are pointing to the fact, John McAfee is quite famous for saying, cryptocurrencies don't stand a chance. Governments like to control the supply of money. This is the truth. Why would they allow cryptocurrencies to flourish unless they were under their control? So it could be that all those cryptocurrencies and altcoins we were looking at earlier, all of them fall by the wayside in favor of government-mandated cryptocurrencies where there's some sort of way of controlling the currency built into it so that the government can do what it wants with it. There's many more risks beyond this, just a few I thought I'd touch on. And I said that was my last slide, but I lied. This, I think, is a brilliant book. And I just thought I'd point it out because in kind of researching cryptocurrency and getting familiar with it, there's many different resources out there that kind of give you half the story, 1% of the story. And this book I found was the clearest work that I found on it. And it's just a great book. And if you want to really get to grips with the underlying technologies of Bitcoin and understand how it works, I would suggest reading that. That's my talk. I hope you enjoyed it. Happy to take any questions.
Has anyone got any questions? Any questions, or you want to do them at the end? Do you want to do them at the end, or we'll do a couple now? Yeah, sure.
What's going on?
Wait, just hang on. So,
pardon me? I've thought about it. I think it's too risky personally. I don't want to end up in jail. So I would stay away from ICOs unless you have some serious legal backing, some legal friends that can help you out. But it does seem very tempting. And I think in my view, I'm an iOS developer by trade. In my view, right now, in the early days of the iOS ecosystem, there are all sorts of apps that came to the fore for really obvious use cases, calculators and, fart machines, what have you. And I think we're at that point with ICOs. We're seeing ICOs appear out of nowhere for all sorts of obvious use cases. Right now, it's very difficult to think of a novel app idea. There's millions of them out there in the App Store. But that's kind of the way I feel about ICOs right now. And it's not very difficult to find something to actually kind of bring to life. But it's incredibly dangerous. I don't know if you're familiar with Kik, which is a messaging app that's really popular with teenagers. They did an ICO in Canada, they're a Canadian company, but they actually refused to actually sell any of their tokens in Canada because they were scared of being caught out by Canadian regulators. And actually you find the same in the States. Many American companies that are doing ICOs, they won't sell their own tokens in the States because they're worried about falling foul of SEC legislation. It's very dangerous. It's serious white collar crime if you're not complying with the regulation. It's dangerous. So. Anything else?
Is this a microphone? Wow, it is. I was fascinated by it.
Impressive.
So, Rich, come on, tell us in real money how much Bitcoin do you have?
I'll never admit it. I'll never admit it. But no, I did. I was lucky enough to buy in at a very early stage, both with Ethereum and Bitcoin. So that's made me happy. But it's all airy-fairy money that probably will amount to nothing in the long run. So.
Answered like a true politician.
Any other questions?
Catch.
How much did those drinks actually cost you in Shoreditch?
In today's terms,
In Bitcoin?
Over £1,000 for 4 drinks. So, yeah, I feel a bit silly.
Okay,
So we had a question over here. Yep.
Okay, sorry. You can catch this as a mic.
What do you think about cryptocurrencies being used by IoT devices instead of people?
By what, sorry?
IoT, like Internet
Internet of Things.
Yeah, I think that's like
that could be an interesting application. Like, what sort of value would the cryptocurrency encapsulate?
I would feel like I would be a bit skeptical about putting my credit card information in my fridge or something. But if I could just have it pay with cryptocurrencies and get groceries and stuff.
I think that's kind of a cool idea. Yeah, why not? I'll be excitedly waiting for your ICO.
Soon.
Anyone else? One last question, anyone?
Cool. Okay.
Cheers, Richard. Rich, that was great. Thank you. I still know nothing about Bitcoin. The next individual that's kindly taken his time to come and present for us, he doesn't actually work for 101 Ways, which is great because it's someone that's been introduced to me, one of our old consultants. His name is Charles, currently working on site at Sainsbury's, I believe. And he's going to give us a great introduction into React Native, which I'm also looking forward to. So I will hand you over to Charles. Shall we have 5 minutes of break? Should we have 5 minutes break or? Good idea.
Oh, the camera, yeah.
Okay, guys, if everyone wants to take their seat again, that'd be great. He's gone. React Native. I think he's run off. That's true, yeah. That's fine. 20 minutes is good. Oh my god, okay, yeah. There we go. Okay, Charles, over to you.
Thank you. Yeah. Hello, everyone. I'm Charles Szilagyi, and I'm going to give you a quick overview of React Native. If you have any questions about almost anything, nothing very personal, but just shoot. And
we have the cube for any questions.
So this is going to be about React Native, and it's going to be probably a little bit more technical than the previous one. So if you fall asleep, I understand that. So let me just try to define what React Native is. So basically, it's a framework created by Facebook a few years ago, which allows you to create real mobile applications, but you don't really need to rely on the native languages to do that, but you can use the almighty and really popular JavaScript language. It's called React Native because the views So how things look like, what colors they have, where are they on the screen, etc., etc. It's all defined by React. And I assume you all know what React is, or I really hope so. Otherwise, this whole thing wouldn't make any sense. To be honest, I was prepared for 5 drunk developers, but that's completely different what I got. So what React Native does is allows you to define how your application looks like and what it does in JavaScript and React. And it passes that whole thing through a thing called JavaScript core, which is a native implementation of our JavaScript parser, interpreter. And so it runs really, really fast, and it's really responsive, and it really feels like a native application. It's all done in JavaScript, but it allows you to put in any amount of native code you want. So you really get the best of both worlds, native Java, native Swift, or Objective-C and JavaScript. So if you ever done React, you can look at this example of a React Native application, and you can try to find the differences between React and React Native. I'm not gonna make you look for very long. There's nothing different. So it's exactly the same thing as you would use to create a website. It's the same JavaScript module system. It's the same type of classes. Same, pardon? Yeah, there's no difference. Yeah, so in any React framework, you can find best bespoke tags like this view thing or text. So that's really not different in any way. So if you speak JavaScript, it's super easy to get started and actually do something and get things done. The styling and the layout of your application is also done using a web technology. The one is called Flexbox, which is for laying out things. So it's a sort of grid system or layout system. Use the exact same thing as you would use in a modern browser. Otherwise, you just use inline styles with this special notation, this camel-cased property names, but it's basically just CSS all the way. And the recommended way to do it is actually to use big objects and pop it into the components as properties. So what's good about React Native is it gives you a really, really great developer experience. It's really easy to get started, really easy to bootstrap a project. It takes far less time, I guess, than native ones. I do have a nano degree in iOS development. I've had to build like 5 or 6 medium-sized applications, and I always find it really painful to work with Xcode and iOS, and it really it's a drag. With React Native, you have live reloading, which reloads the whole application when you change something. But you also have hot reloading, which is basically able to have a look at what changed in your code base compared to what's on your phone, and just changes just one little tiny bit at a time. So the refresh rate is like 1 second. You change the text, it takes literally 1 second to see the change on your phone. If you're working on a page which is really hidden deep in your app, like a registration step that would take 5-10 minutes to get to, you can still work on that one step and you see the changes instantly, and you don't have to redo the whole process again and again and again. And I've borrowed someone else's presentation on that, hot reloading, from YouTube. And let me just play that. It takes about a minute. So obviously, black side is the code used to style your UI, which is clearly some CSS. The right-hand side shows you the emulator. the running application. And as you can see, it's completely, it looks completely native, and it is actually completely native. And that's it. I just see one more change and then we move on. It was worth it, turning it to blue. But as you can see, it's really snappy. So there's no lag. You don't need to recompile your whole application, and you don't lose the state of your application when you make changes. As you can see, the list, all the data that was behind the application stay the same. You can just change the presentation, and it just finds out the difference and updates it in your app. I'm going to get back to that fact at the end when I talk about the benefits, but I think this is a really eye-catching difference from native Android or iOS development. Thank you. So very briefly, how do you get started with React Native? You will definitely go to React Native's website, which I'm going to show you at the very end. But basically, these are roughly the 3 steps you need to run to get a fully working development environment up. Once you have Node.js, assuming you are a JavaScript developer, you already have that. You can just type these 3 lines of code, and you see a working native application running on your phone, and the shell for your application is already ready for you to work on. You already have a React component as a top-level application, and then you're free to include anything you want to and be as thorough and as custom as you want to. I'd like to highlight that this solution has nothing to do with the likes of Cordova and stuff like that. So it's not trying to run a website inside your browser, inside your phone. It is really running a business logic in JavaScript and then rendering a native UI element. So like I said, there's really very little boilerplate. And to be honest, I think these 4 lines are all that's very specific to React Native if you're a JavaScript developer. So there's one app registry where you need to register your main top-level component of your React app. And once you kick that off, this app.js or app.jsx file, you're free to do whatever you want in React. And then you're free to use Redux or whatever other state management tool you want to use, et cetera, et cetera. An interesting thing is Facebook was trying to be sensible about how universal this solution is. So how they promote React Native is that it's not a learn once and write once and then it runs everywhere solution, because it doesn't. You need to sometimes pick specific UI elements for specific platforms. As you can see, some are cross-platform, like the image, it works on every platform React Native runs on. Sometimes you have Android-specific ones and you have iOS-specific ones. But I'm going to show you a little trick which allows you to create your own domain-specific components that are sort of transparent, and then you don't really have to worry about that much. As you can see, I've listed 3 files, one for web, one for iOS, and one for Android. And with a little work, you can set up your dev environment. So when you say, compile this application for me, the bundler, most likely is going to be Webpack, is going to pick out the right file if there are multiple ones to pick from. So if you're working on an iOS app and then decide to port this thing to Android, let's say, you can just find the specific bottlenecks where it won't run on Android, and you can substitute them with an Android specific solution, and React Native will find it. You don't really need to put in ifs and switches into your code, or you don't really have to worry about what platform you're on at runtime. Another interesting thing is that the Storybook solution, which is very popular for React web developers, and that allows you to build a beautiful design language and a showcase of your components, also supports React Native. So you can create your storybook for web, and you can also create your storybook for React Native at the same time, and you can connect the phone to your laptop and showcase it for your clients, or it just simply allows you to work on one component for a phone in isolation, which I think is very unique in mobile application development world. So what about code reuse? Like I said, the solutions you create with React Native are not 100% portable between all the platforms it supports. But according to Instagram, their application in which is available on both iOS and Android shares roughly 90% of the code, which leaves like 10% platform specific. And I think this is a really, really powerful number just to look at. Certainly, there are some problems, situations where you have to tap into the native capabilities of your phone. React Native doesn't bundle every imaginable solution into its framework. So, for example, if you need a barcode scanner, you will need to install a bridge which exposes a JavaScript API on one side and talks to the native API on the other, and allows you to just simply do things like get barcode and then run with it. And all the rest is handled for you, and you don't need to worry about iOS specific problems or Android specific problems. The same way, you can embed whole mobile SDKs if you want to. So if one example would be, probably some of you are familiar with Paycasso, or more likely, most of you probably are registered with Monzo and similar services where you need to verify your identity with scanning your password on your phone, looking in the camera, etc. So that company allows you to use a mobile SDK on Android and iOS. But when you're working on a React Native application, they obviously don't support React Native, so it sounds like a deal breaker. But based on my recent experience, it was really, really easy to create a wrapper for this mobile SDK, which was written in Objective-C to make it work from JavaScript on iOS. It took us roughly 5 to 7 days to achieve that. And we could just use the whole solution, and we could just kick off an identification process from JavaScript. And it took over your application, allowed you to scan your face, scan your passport, do whatever is required. And when it was done, the control went back to our JavaScript application, and we just got the results and did whatever we wanted with it. So we are nearing the end-ish of this presentation, so I'm going to briefly summarize what we talked about. So based on the experience, probably React Native is the best for applications that are a little bit like websites, but that means it's good for almost everything, but not necessarily everything. So what I mean by web-like applications is shopping applications are definitely good candidates for React Native. If you want anything based on anything data-centric, like searching for something, or real estate, ordering stuff, ordering food, let's say, banking, etc., etc. So if it's data-driven, you're going to have a very good experience with React Native. If it's very heavy on graphics, it's more like a game, or very image-heavy, video-heavy. You might be better off with a native solution, but it's worth a try because React Native is getting better with every release, and it's getting faster with every release. So the experience shows that the performance is quite solid. You don't really have much to worry about, and you have your usual tools, usual JavaScript tools to get things fast. Now, some of you probably don't really link JavaScript with performance, but with the modern tools we have in JavaScript, you can really make good performing, very intelligent solutions for optimizing your data flow. And you can just stop rendering your application if it's not really necessary. So you can achieve a really high FPS in your app. The animations were a little problematic in older versions, but recently a few very good solutions came out, and you can be really declarative with your requirements. So you can just say, I have this box and I want it to ease in slowly and then just fade out, I don't know, fast. And that's all you have to do. You don't really need to do calculations. You don't really need to go into the math. You don't really need to tap into the native APIs of the phones. All that is hidden from you, and you get a really, really quick turnaround and beautiful animations, and they are really high performing. Let me just finish this talk with what I call the story about the pit of success. And I wanted to zoom out from React Native as a JavaScript and React solution and talk about how it fits very well into a bigger stack of technology, and how it can serve much more than just mobile applications in an enterprise. So what I have found in several roles previously is if you're trying to be fast and lean and try to achieve a real high velocity in your team, you are able nowadays to attack your website, your services, iOS and Android applications, and who knows what, even robots, if you're into that, with JavaScript. Which brings the benefit of using just one language, just one IDE to learn, one toolchain to pick up, one coding style, basically just a very small team of like-minded developers, which probably doesn't sound really powerful at first, but if you think about it, you don't really have a fragmented solution, and you don't have a fragmented developer team, but instead anybody from the team can pick up basically any part of the project, even for a larger undertaking. And even junior web developers can be assigned to fix problems on iOS applications, which is, I think, really, really amazing. Because not every problem you face on a mobile application is a big one. So sometimes you just need to fix colors, you not just to fix layout, you just fix copy, etc., etc. So you don't necessarily need to be a black belt iOS developer to deliver something. Yes.
Going back to the wrapper that you built in 5 to 7 days, was that just you? How many people? How many engineers doing that?
So that was done by one developer who was experienced in Objective-C, and I was helping with the JavaScript side. But that was really tiny. So I failed to put in enough examples. I didn't know how much examples you want to hear, but basically the JavaScript side was only calling one function, it returned your promise, if that means anything to anyone. And when that promise returned, you got your answer. If it got rejected, that was a problem that you had to handle. But basically, that's how high level and how declarative you could be with this SDK. Let me just get back to that sort of declarativeness in a second. What also becomes available using React Native and JavaScript in general is your reusable views for a whole host of applications you're working on. So if you're a bigger enterprise and you try to kick off multiple projects and you work on multiple fronts, you can have a centralized repo for all your views, all your presentation layer logic, because your components could very easily just work across all platforms you were trying to attack. And I think what's even more interesting and more powerful, much more powerful, is that you can actually extract out the logic from your applications, because if they all run JavaScript, they can be all JavaScript. So you can share that logic between your projects, and you don't have to reinvent the business rules in different languages, and then you don't have to retest and redevelop the business rules and your use cases in multiple languages. You can just say, let's npm install, I don't know, just eat core npm module, and it's going to handle all your ordering logic, and it's going to validate all your inputs, etc., etc. And it can do it on all platforms most platforms you're targeting, which is really powerful. So obviously, JavaScript ecosystem is the largest one of all programming languages. It has a lot of rubbish, bad modules, but it's bound to have a few good ones. And like you can see, we have over 7,000 packages for React Native on NPM. Some of them do things like helping you with navigation. Some of them help you with barcode reading. Some of them help you with payments, offline problems, etc., etc. So it's a really, really rich resource to tap into. I cannot really imagine that richness in other languages, especially not in a language that allows you to attack multiple platforms at the same time. In my opinion, the biggest win when going for something like React Native on a mobile application is that it allows you, with the modern practices of JavaScript, to create a really clean architecture and to really separate your problems inside your application. Meaning, unlike at least my experiences on native solutions, you can completely cut out and separate your business logic from the presentation. You can completely separate out your state from presentation. You can separate out all the networking into submodules, which don't know nothing about the rest of the application. And they can be all beautifully tested and can be high quality. And you can refactor them, you can modify them, you can work on them in isolation, and they just all come together in a really beautiful way when you deploy the app. And let me just finish with this slide that tells you that JavaScript nowadays is it can be a really modern language. It can be really declarative, which helps teams immensely. You can just express your intentions, and then others coming into the project just can understand it really easily, really quickly. You can be really functional, not as some languages, but there are tools that allows you to be really functional, and you can be really modular, and you can reuse a huge amount of your own code that you create with very hard work, and over the long run, it really pays off. Type safety is there in JavaScript. You can have TypeScript if you want to buy into that, but you can also have Flow, which is a very lightweight solution. It's an opt-in solution. You can just select which files you want to type check, which properties, or which objects you want to type check. So it's a really flexible and nice solution. And I think if we put all this together, all these pieces of the puzzle together, JavaScript on multiple platforms, on the client side, on the apps, in the servers, JavaScript being a really modern language, it can be a really, really powerful, declarative, functional, and clean language. I think it just really brings a huge power and huge benefit to anyone who invests into it. And I think that's it. Thank you.
Okay, got any more questions, anyone? Oh, okay.
Yeah, I'm just curious about how it interacts with like basic phone components like accelerometer and cameras. Do you need any extra like wrappers and stuff like that, or can you just use them out of the box? Yeah, maybe like
I think camera is fine. So it just comes bundled with React Native.
And things like accelerometers as well, or like
Pardon?
accelerometers, like the sensors. Or...
I'm not sure about that.
Okay.
I'm sure there are solutions. But worst case, you need to install a module and then
it just works. Hopefully.
Yeah. It definitely does, but I'm not sure if it's bundled into the React Native core or
So with the web applications, the CSS frameworks, for example, Strap, with React Native, there's something equivalent to that, because I'm a backend developer and I'm really bad at styling stuff. So if there's some framework for styling, then yeah, might be.
I'm sure there are multiple ones, So you can, if you Google for React Native UI library or something like that, you're gonna have at least 5 high quality ones.
Right. Is there any you recommend? Or do you normally don't?
No. I don't remember any. I haven't used any, so I don't remember any names. But it's really just a Google search away. I'm pretty sure there are a few really powerful ones.
So presumably you're a web developer as well. So do you use any web framework, or because you're maybe very good at CSS, so you just write your own style sheets?
So for the last few projects, we went for bespoke solutions. So probably you reused something like Bootstrap Grid, but that was the most. I don't see why you wouldn't be able to use, even if you just start out with React. React already has really high quality, very rich libraries. I can give you my email, and I'm really happy to send you a few links. There are tons of React specific ones.
Right. Thank you.
We've got one at the back, and then obviously you'd like to catch it.
So you talked about how it encourages a bit of success by allowing you to write modular, reusable code. How much of that is something that you learn how to do after you've done your first couple of goes and realize that it's a mess? Or does it actually kind of force you down that route from the word go? How easy is a module to extract from your big ball of mud that you've shipped and it's prototypical and it's great and it's making money and shit, you need to make changes?
It doesn't help you like that. It doesn't work like that.
Because you can be modular and lovely with CSS and JavaScript if you know what you're doing from the word go, right? So does it have any advantages over that?
So what I find really powerful. Okay, let me just clarify that. So recently there was a surge in JavaScript world where a few really talented people came in who were not jQuery hackers and just people who just did things, but they really knew what they were doing, and they created stuff like Redux, and Facebook contributed a huge amount of really high quality open source solutions. So if you look at those solutions and you understand why they work the way they work, and probably Redux is a prime example for that. If you're willing to spend the time and understand why it does what it does, you're bound to separate out your different domains or problem domains into separate modules. But React Native itself, and obviously JavaScript itself, it's not going to take your hand and show you where to put stuff. Just like, I don't know, Java doesn't really help you to, by default, to solve these problems. What I'm trying to get to is if you look at the up-to-date version of how big companies do JavaScript, like Facebook, Airbnb, not Google, they are horrible, but you have very good examples. Then you're going to see that your state management is completely separate. It's a unit-tested, beautiful, separate entity. Nobody has anything to do with it. Your view is just a dumb function that gets data, spits out a beautiful view, and that's all it does. And so on and so on. So you can, if you follow these examples, you're going to fall into a very good pattern, I think.
Yeah, I got a question just overall, because like I never really got into mobile app development through the web frameworks. But I think at the moment, progressive web apps are really getting the traction, right? Especially we had chat before. I was saying that with Google Dev Summit, there's been quite a few examples. For example, Trivago done a progressive web app, and they've seen amazing increase in conversions. Same with Instagram, they done a progressive web app rather than an application, and they've seen amazing engagement. I think 40% engagement increase, as well as advertising viewability and click-through, also quite high. And then as one of the mentions you did was that React Native is useful for kind of webby things. Do you think with the rise of progressive web apps, if this is gonna PWA is gonna take over, or when would you use something like this? When is a good example to build an app? I think maybe it's a more general question overall rather than specifically React Native, but I'm kind of very confused the more I read about it. If I want to build something for mobile, which way to go down,
Yeah, it's a really good question. There's always multiple ways to skin a cat. So if you have a rough idea of what you want to achieve, and you don't really need native capabilities to that, you don't want to take photos, you don't want to upload files from your phone, if you don't need location, but you get that on a laptop or you get a phone. So, but if you don't rely on native only capabilities, then it might work. I don't have a huge amount of experience with these thin little web apps, but I'll say why they wouldn't work. So obviously they do work. They are very nicely thought out. So the idea behind them is great, and that's what the web was trying to be for a long time. So you just have applications that run whenever you want them. You don't need to pre-install them. On the other hand, I guess there's a prestige with being in an app store, which is one thing. You might need all the processing power of your native capabilities to run what you want. Not like I have run into that issue any time before. Yeah, I cannot really think of any good reasons if you're just going for a very web-y application. Now, one example comes to mind. The previous project I was working on, a financial company wanted to deliver a mobile investment solution to people, but they needed an identification process. So you had to open the camera, you had to scan passports, etc., etc. You had to rely on the native SDK that they provided. So I guess that would be a deal breaker. But but probably there's no clear-cut line. It's a bit fuzzy, I guess.
I guess as well, where you mentioned with the build run, with the build time, you can still reuse lots of logic, so you can still probably build an app and then a cut down version of progressive web if you need to.
There's also a thing called React Native Web, which is a complete perversion of the whole idea. It just goes, so there was React for the web, then React for mobile phones, and then somebody came up with the idea, okay, let's do React Native for the web. So you do stuff in React Native, and it allows you to run on a website. And it sounds completely crazy, but it's actually not that crazy because you can showcase your stuff remotely. So it's not as stupid as it sounds. Cheers.
I want to thanks again to both Richard and Charles. So yeah, thanks again. One more round of applause. Those guys. Also, special thanks to Just Eat and Michael Sipe for actually making sure we secured the room. I know you helped as well, Richard, but I think Michael's accepting beers downstairs at Jamie's afterwards and shooters. And that's, I think, us. We are our next event is actually on the 29th of November, where one of our other club captains, Tun, will be speaking. Will give us an intro or an overview into machine learning, which is going to be really interesting. Is that right? Machine learning. Sweet. There may be another speaking spot as well. So it's open to anyone. Just something that's interesting. By all means, just give one of us a shout. But I will see you once we've all I need a hand packing up, but then I'll see you for a beer downstairs at Jamie's afterwards. Cheers, guys. Thanks again.